Theorem: prove that the characteristics functions of the Sturm Liouville problem with respect to the functions involved in the problem as the weight function are orthogonal. Statement: consider the Sturm Liouville problem of the differential equation d over dx of px dy over dx plus qx plus lambda rx into y equals to 0, where px, qx and rx are the functions such that px has a continuous derivative, qx and rx are the continuous, and px is greater than 0 and rx is greater than 0 for all x on a real interval. A is less than equal to x is less than equal to b, and lambda is a parameter independent of x, and the conditions a1ya plus a2y dash a equals to 0, b1yb plus b2y dash b equals to 0, where a1, a2, b1 and b2 are the real constants such that a1 and a2 are not both 0 and b1 and b2 are not both 0, and if lambda m and lambda n be the two distinct characteristics values of the problem, the phi m and phi n be their corresponding characteristics functions, then the characteristics functions phi m and phi n are orthogonal with respect to the weight functions x on the interval 0 is less than x is less than equal to b, that is integral a to b of phi m x phi n x rx dx equals to 0. Now proof: the given differential equation is d over dx of px dy over dx plus qx plus lambda rx into y equals to 0. Equation 1. The given conditions are a1ya plus a2y dash a equals to 0 and b1yb plus b2y dash b equals to 0. Equation 2. Since the phi m is a characteristics function corresponding to the lambda m, the functions of phi m satisfies the differential equation 1 with lambda equals to lambda m. Now similarly phi n satisfies the differential and satisfies the equation 1 with lambda equals to lambda n. Thus we have d over dx of px phi m dash x plus qx plus lambda rx into phi mx equals to 0. Equation 3. D over dx of px phi n dash x plus qx plus lambda rx into phi nx equals to 0. Equation 4. For all the x that a is less than equal to of x is less than equal to of b, multiplying the equation 3 by phi nx and the equation 4 by phi m and x, we get phi n d over dx of p of x phi m dash x plus qx plus lambda m rx into phi m x phi nx equals to 0. Equation 5. And phi mx d over dx of px into phi n dash x plus qx plus lambda n rx into phi nx phi mx equals to 0. Equation 6. Subtracting 5 and 6, we get phi nx d over dx of px into phi m dash x plus qx into phi mx into phi nx plus lambda m rx phi mx phi nx minus phi mx d over dx of px phi n dash x minus qx into phi mx into phi nx minus lambda n r x phi nx into phi mx equals to 0, or phi nx d over dx of px phi m dash x minus phi mx d over dx of px phi dash mx plus lambda m minus lambda n into phi mx phi nx rx equals to 0, on or lambda m minus lambda n equals to phi mx into phi nx into rx equals to phi mx d over dx of px phi n dash x minus phi nx d over dx of px phi m dash x. Equation 7. Integrating 7 with respect to x from the limits of a to b, we get lambda m minus lambda n integral a to b of phi mx phi nx rx dx equals to integral a to b of phi mx d over dx of px into phi n dash x dx minus integral a to b phi nx d over dx of px phi m dash x dx, or lambda m minus lambda n integral a to b of phi mx phi nx rx dx equals to phi mx into px into phi n dash x limit a to b minus integral a to b px into phi n dash x into phi m dash x dx minus phi n x into px into p m dash x limit a to b plus integral a to b of px into phi m dash x into phi n dash x dx, or lambda m minus lambda n integral a to b phi mx phi nx rx dx equals to phi mb into phi p b phi n dash b minus phi ma pa into phi n dash a minus phi nb into phi b into pb into phi m dash b minus phi na into pa into phi m dash a equals to phi m b P of B phi n dash B minus phi m A P of A phi n dash A minus phi n B, taking this minus sign and opening the bracket. Here only the plus sign will change, so phi n B PB phi m dash B plus phi n A PA and phi m dash A, or lambda m minus lambda n integral a to b of phi mx phi nx r x dx equals to, taking P of B common, phi mb phi n dash B minus phi n B phi m dash B minus PA into phi MA phi n dash A minus phi NA phi m dash A. Equation 8. Now the following cases arises. The case 1, if A2 is 0 and B2 is 0, then the condition 2 reduces to A1 YA equals to 0, YA is 0, and B1 YB equals to 0, which implies YB is 0. Therefore, in this case, phi MA is 0 and phi MB equals to 0, and phi NA is 0 and phi NB is 0. Thus, the equation 8 gives lambda m minus lambda n integral a to b phi mx phi nx rx dx equals to P of B 0 minus 0 and P of A 0 minus 0. In this equation 8, in these both terms will be equals to 0, as we have the value of phi m and A and phi mb and phi na and phi nb is 0. So this equation equals to lambda m minus lambda n integral a to b of phi mx phi nx rx dx equals to 0. But the lambda m not equals to lambda n, therefore we have integral a to b phi mx into phi nx into rx dx equals to 0. Case second, a2 is equals to 0 and b2 not equals to 0, then the conditions 2 reduces to a1 ya equals to 0 or ya is 0, and b1y plus b2y dash b equals to 0, which implies b1 upon b2 yb plus y dash b equals to 0, which implies beta y dash b plus y beta yb plus y dash b equals to 0, where beta equals to b1 upon b2. Then in this case, phi n a equals to 0 and phi m a equals to 0, and beta phi m b plus phi m dash b equals to 0, and beta phi n b plus phi n dash b equals to 0. So the equation 8 becomes lambda n minus lambda n integral a to b of phi mx phi nx rx dx equals to P of b into phi m b phi n dash b minus phi n b into phi m dash b minus P of a 0 into phi n dash a minus 0 into phi m dash a equals to p of b of phi m b phi n dash b minus this term will p of a containing term will equals to 0 minus phi n b and phi m dash b now equals to p of b of phi m b into phi n dash b minus phi n b phi m dash b plus putting the values beta phi m b phi n b minus beta phi m b phi n b equals to p of b phi m b into beta phi n b plus phi n dash b minus phi n b into beta phi m b plus phi m dash b equals to probability equals to p b into phi m b into 0 and phi n b into 0 using the conditions as we know the condition these phi and this according to this beta phi m b and phi m dash b equals 0 and beta phi n b and phi n dash b equals to 0 in this equation this term and this term equals to 0 and so we have phi mb into 0 and phi nb into 0 so this is equals to 0 so integral a to b of phi mx phi nx rx dx equals to 0. Similarly, if we have a2 not equals to 0 and b2 equals to 0, we can prove that integral a to b phi mx into phi nx rx dx equals to 0. Case 3, if a2 not equals to 0 and b2 not equals to 0, then the condition 2 reduces to a1 ya plus a2 y dash a equals to 0, b1 yb plus b2 y dash b equals to 0, or a1 upon a2 y a plus y dash a equals to 0, beta 1 upon beta 2 y dash b plus y beta 1 upon b2 y b plus y dash b equals to 0, or alpha ya plus y dash a equals to 0 where alpha is a1 upon a2 beta yb plus y dash b equals to 0 where beta is equals to b1 upon b2. Then in this case we have alpha phi ma plus phi dash ma equals to 0 and alpha phi na plus phi n dash a equals to 0 and beta phi mb plus phi m dash b equals to 0, beta phi nb plus phi n dash b equals to 0. Then the equation 8 gives lambda m minus lambda n integral a to b phi mx phi nx rx dx equals to p of b into beta phi nb into phi mb minus beta phi nb into phi mb plus phi mb into phi n dash b minus phi nb into phi m dash b minus p of a into alpha phi n a into phi m a minus alpha phi n a into phi m a plus phi m a into phi n dash a minus phi n a into phi m dash a equals to p of b of phi m b into beta phi n b plus phi n dash b minus phi n b into beta phi m b plus phi dash m b phi m dash b, or p of a into phi m a into alpha phi n a plus phi n dash a minus phi n a into alpha phi m a plus phi m dash a equals to probability or equals to p of b phi m b into 0 minus phi n b into 0 minus p of a phi m a into 0 and phi n a into 0, because this term in the previous condition, as we have proved, equals to 0. This term and this term will be equal to 0, and this term is also equals to 0. So in this place, putting the 0 equals to this equation will become equals to 0. Thus we have lambda m minus lambda n integral a to b of phi m x and phi n x r x dx equals to 0, which implies integral a to b of phi mx phi nx rx dx equals to 0, because lambda m and lambda m not equals to lambda n. So all the cases we have integral a to b of phi mx into phi nx dx equals to 0, and so the phi m and phi n are orthogonal with respect to the weight function rx on a is less than equal to x and is less than equal to b.